Okay, welcome to the software engineering methods, and of course you might have noticed that this lecture is not actually a lecture from the live audience, or this is not something that was recorded during the Friday morning lecture session, but this is a replacement for the second lecture on which we will talk about software process models, because I'm traveling for the second lecture week, and I think that we have to have some sort of a quick summary or quick outline of these topics, since we already have lost 2 weeks to our new course structure, and I think it's important that we have at least 12 weeks which our current courses take. So last week we were talking about the software engineering and development of information systems, in a sense that what actually is software engineering, what's software development, what are software engineering methods, and what's development of information system. So today we are going to talk about the actual act of developing software, or developing the software component of information system, by talking about software process models, which more or less are only a formal or formalized way of conducting the activities needed to design, implement, and test, and also taking to use some sort of software system. So going into the software process models, we start simply by defining what's the word process. So basically there's no magic or anything like that involved here. The diagram here gives us the basic idea of what the process and process models actually mean. We have development need, and to give an answer or solution to this need, we want to have a new and enhanced system. So the process here is more or less just the steps defined how to systematically, with some sort of control system or ability to manage what we are doing, we are trying to gather the needs and create an answer or solution that would fulfill all our requirements and needs for the system. So basically it doesn't have to be that fine-tuned or refined approach, but of course, since we are in this course, we will be talking about some of the more formal or more transferable process models. But for example, something simple like waterfall approach, or anything where you basically just talk with people, design something, do programming tasks, do testing tasks, and publish, for example, your mobile game. It involves a process, but in industry, or at least on this course and in general, we mean the more standardized development processes. For example, the rational unified process, which we will be using as one of the examples on this course, is one of the more standardized transferable development process models, which aims to offer guidelines or steps to get from any situation, or be able to modify the process model to fulfill any sort of need for developing any software, be it games or embedded systems for anti-lock brakes, or avionics or military applications, basically whatever. So the idea is that the process defines all the necessary aspects and all the phases of activity what we will be doing when we are developing software. So basically, the more simplified version of this rant I gave you is that the process defines who does, what does, when, and how. So who will be doing things, what will be done, when it will be done, and how it will be done. The people, the model, the paperwork, the amount of design, the software tools applied, when are we going to have meetings, do we have reviews, all the things needed to get from requirements to new system that tries to fulfill the identified requirements. So the lifecycle model, it's more or less the same thing that process model. The lifecycle model is something which a bit expands beyond the process model. The process model, or software development process model, means that we are establishing what will happen between getting the idea of what sort of software we need to when we get the software online or put it available in App Store or somewhere else, whereas the lifecycle model is more or less concerned about every aspect from the start of the software to the end of its life cycle. So meaning that when the platform is finally abandoned, or when the new version of iPhone is no longer able to support your current application, or when you decide that your software is so old that you no longer can sustain it, or it doesn't make enough money to be kept updated. So the lifecycle model starts with the idea, similarly as the development process models, but the lifecycle model continues until the end of the lifetime of the software, ending only when the last legs of support are cut under your software, whereas the process model more or less defines only things that happen until your software is done. Taking into consideration, for example, with Windows XP operating system, the process development or development of the operating system took something like 4 years, and the operating system was published in 2002, if I recall correctly. And that basically the year 2002 was the end of the first development process, or the development process model of the operating system, whereas the lifecycle model continued with the updates and all the other hot fixes and service packs, and actually the last updates for Windows XP operating system were written as late as 2012, meaning that basically the software had a life cycle of about 15 years, but the process of developing the software took only 3-4 years from the start. So considering that, well, of course the life cycle model is something that's more interesting in a marketing sense, because the life cycle model also talks about how to make money from the software, for example, or how do you have to support your software or do continuous projects to create DLC additions or expansion disks or additional content or whatever. But on this lecture we are focusing on the actual process model, the act of making the software. So for this we have several actual high-level models that we usually use. The waterfall model is something that's usually the first thing introduced because it's quite simple and straightforward, but there's also more adaptive models like iterative model, incremental models, prototyping, agile approaches like Scrum or XP, and we will be talking about all these models today, but we will start with the waterfall model. So the waterfall model is more or less the hello world process model example of the software engineering methods world. The waterfall development model is really simple. All the phases, the analysis, design, implementation or programming, testing and support are sequential, meaning that once you are done with gathering requirements, you go into the design. Once you are done with the design, you go into the development, and so on and so on. So it's really simplified. Of course, this means that we have to always start and end a phase. For example, the design phase, where we design architecture and the user interface and stuff like that. And then we just deliver all our stuff, artifacts, documents, plans, designs, programming code to next phase, where we are elaborating based on that result. Of course, it means that there's also lots of milestones, reviews, decision points, but they are all at the end of each phase, and once we make the decision that, okay, this is it, and now we go forward, we just start to do the next thing. So in purest form of waterfall approach, there's no overlap. We design once, then develop, or there's no feedback loops, meaning that if we decide that, okay, this design is faulty, we cancel our decision or revert our decision to go into development or do some additional development work and then continue with the development. So basically the idea is more or less this. At the first phase, we gather requirements, do some requirements analysis and specification, for example, to understand what our customers really need, what sort of features our software actually needs, and all the other things related to defining how our system should be built, or what are the limitations or capabilities of our hardware. For example, identifying how many 3D objects we can handle, for example with iPhone, before having any problems with the stalling playing speed, or how many sensors we can use with some firmware system before we are having troubles with maintaining real-time or close to real-time requirements. Then when we have all the requirements and limitations and needs, then we do design work, where we more or less draw the map or draw the outline of the software we want to have, and possibly even do some prototyping work with our customers to establish what sort of user interface we want. And when we are satisfied with this design, then we construct everything, do the drawing work, do the programming work, do all sorts of unit testing activities and stuff like that. And after we have constructed anything and we have a full functioning system, we do testing to more or less just ensure that all that we designed is actually something that we made up. Well, not made up, but created. And ensuring that everything works, the system boots in the environment it was meant for, or that everything works correctly. And then when we are established that okay, everything works, then we just put the thing on sale or in operation and do simply some small maintenance operations. And in the rare case where we find out that something we designed isn't working, or something that we constructed isn't functioning, or something that we decided on requirements analysis and specification isn't functioning, we can always go backwards and do revisions, but that's something that's not expected. Okay, so that's the idea of waterfall, and you can see that the idea goes from the fact that it just flows forward, and the general gist is that you start with some forms of discussions or collected information do technical design, start to create technical construct, see that everything works, and then put your system online or available, or start selling it to your potential customers. So, what's wrong with this? What's wrong with waterfall? Because, well, it seems like it's an engineer's dream. You specify stuff, you design things based on your specifications, you do construction work, programming work and drawing work and all that stuff based on your own designs, you test things to ensure that you built everything correctly or that you didn't leave any typos or programming errors into a system, and when you see that everything works, you take things into use. So, really straightforward and really optimistic saying that everything should function this way. So, this is really simplified approach. So simple actually that this idea of phases, or idea that we have specifications development, or we have design phase, or construction phase, or test phase, quality assurance phase, is more or less in the commercial contract lingo. So saying that you have quality assurance period, or the customer has to approve certain things, or that you can only start doing development when the customer has approved the design, and also meaning that the payments from the customer to your company usually are more or less decided on when you are able to show sophisticated enough design. Of course, if you are building something like a game or a mobile application, the customer only pays you when you are giving your software into use. But considering something that we are doing a large industrial project, we might expect that something like 15 to 50% is paid beforehand, so that there's actually some money to pay the salaries or some incentive to actually start doing the project. Okay, so if this model is something that every engineer by instinct should be able to understand, something that's easy enough to use as a basis for the commercial contract, and something that project management is using for basis of planning work, and it sounds really reasonable. So you have to know what your customer wants before you can design anything. You can't really construct anything unless you have some sort of design. You can test anything unless you have built something, and if you haven't tested something, you would be really stupid to give it to user or put it online. So what's the criticism then? Why isn't the waterfall working? So the simple answer is that, well, humans are imperfect. Everyone is imperfect, and people tend to lie, or people don't know what they're talking about, overestimate the capabilities of, we can overestimate the capabilities of our customers or our standard users, or that the platforms keep varying so much that we are unable to get the system functioning. If we designed our application 2 years ago for the phones used at that time, and we are trying to do multiple year project, and we are launching our project now, the phone may no longer be able to function that way. There's actually a very good design error, or very good example of this design problem in one of the mobile navigation applications, where the system was built so that it actually ran well, completely fine, but all the maps and stuff were read from, or delivered with memory cards. So, okay, It's a fairly simple idea. If you have your map on a memory card, you can update it. You can buy commercially just a new memory card so that you can get the updated maps and stuff like that. But unfortunately, the modern phones don't have external memory card ports anymore. So if you were designing a software based on some feature like physical cards, memory cards used as your database storage, which by that time was completely reasonable expectation, and you would be releasing something now, you would be completely screwed. So that's one of the reasons why waterfall model doesn't actually work. It's really simple and it's really powerful, yes, but only in paper. For example, there's no way to collect all the requirements at the start. You can't know everything before you have tried something out. There's always some hiccup or some problem or some customer group that you didn't expect, or some additional requirement imposed by changing laws or something like that, that will at some point break your project. There's also the problem that the waterfall really doesn't give any idea to change requirements or abandon them once we have committed to our work, because we will never, in purest form of waterfall, do any review work on the requirements, or we don't see that if they are still valid. Well, obviously people are wrong many times. People may be talking some about things that they don't know about, or they may give you an opinion which may change during their lifetime. So you really can't always rely on your customers. Even your customers may not actually know what they want, and if you want to fulfill all the requirements your customers want, then you will be doing something that's so huge and expensive and difficult to get to work that you probably will never deliver anything. So that's also a problem. And also, if you ask someone to design or define the best game you ever would play, something that doesn't exist, but something that you would absolutely play if I would make you one, then most people would give you some vague guidelines, or something like Saints Row 4 combined with the TIE Fighter type of space shuttle management, or anything really. But you can't say that your customer would be able to say what sort of game they would like if they don't have any prototype or anything to actually bounce their ideas against. Of course, not only do the people's tastes and ideas about good attributes change, also the platform is something that will change. My example, which I just told about, the navigation software for mobile phones, was one of the more concrete examples. The platform changed so that it's actually cheaper for the phone manufacturers to create a phone without external or physically available memory card port or connector. So basically, that's a platform change that's completely understandable. Since we are now distributing our software digitally, and there's a really huge competition on phone prices between different companies like Samsung or LG, Apple whatever's left of Nokia. Those companies are always competing who can make the best phone with the least money involved in the physical components. So of course they will eliminate the memory card feature. And well, that's a change, and from the software developers or software designers viewpoint, that's just one thing you have to do without. If you are building a software or requiring that our software will have to use the memory card approach, we will not do digital distribution, well then you would be out of business quite soon, because no one sells hard copies of their games for mobile phones via physical memory cards anymore, or more or less any application, simply because the changes in the platform made part of your customer base unavailable. So you have to change your approach, and I think that particular navigation company made an update to the software where the next version of the software actually pulls the map data out of internet, downloads it to a relatively large sized chase memory, so that it actually functions over digital downloads. But that's something that they had to do because their first design with the physical memory cards was something that didn't work. Obviously, on the other hand, the digital download is only available because the technology has moved forward. So 5-10 years ago, downloading something via data connection on your mobile phone was either completely mad idea to even think about, or it was really costly thing to even try. So obviously that wouldn't have worked then, and they had to make the changes because the platform and their target platforms had grown and the requirements had matured. Also, of course, if you don't know the platform very well before the implementation, then there's always some problem with the optimization and how to get everything to function. The expectation that platform is very well known is actually also a sort of a problem, because even if we have standardized hardware, which is only available with video games or Apple products where there's no variations in hardware, or some cars or someplace like that, where you more or less design also the hardware part of the system when doing the software part, there's always problems that the sensors work other way around that you designed it, or that something simply isn't designed to do what it's meant to be doing. There's one of these sort of problems is more or less that you can design your anti-lock brakes to function really well on paper, but when you get the actual sensor, you have a problem that the element can't stand heat, or that the sensor system doesn't send enough information, or that your processor system is not capable of processing all the data in real-time manner, so you have to revise your design. On a more simplified explanation, simplified example, consider the video games for different generations of game consoles. Since the games are delivered to you via Blu-ray discs or digital downloads, you really can't increase the hardware abilities of your platform. The PlayStation 3, for example, was the same PlayStation 3 whether you bought it from the first day it was available or the last day before the PlayStation 4 was launched, but still the games managed to to advance over the time so that they actually looked much nicer and were much larger or much more advanced than the earlier versions of the games that were released earlier on the PlayStation 3 Lifecycle. That actually is also something that should be mentioned here, because the developers knew more about their platform. They were also able to find and isolate the bottlenecks more efficiently. So that's also the reason why something like Saints Row 2, which was ported to PC, doesn't run in even in new computers very well, simply because the company didn't know anything about the PC architecture or PC optimizations, whereas we have on the other end of the scale have something like GTA 5, which is optimized so that it's actually the only software in PlayStation 3 where you are actually suffering from performance issues only if you are installing the game completely to the hard disk, because it was optimized so that it's actually able to read both the disk and the hard drive at the same time, because that was technically possible. If you install all the disk data to the hard drive, you actually are not using the disk for anything else than to play some audio, and you have to read from two different places on the hard disk, meaning that that's actually slower than playing with the disk system. And that's just something that you had to learn, or you had to know, or had to develop the programming and design techniques to take into account, so that you could squeeze more performance out of your game console. So anyway, the last point in this list also says that the waterfall expects that the problems and bugs are easy to locate and fix from the final product, since there's always correct design and correct build and all the right requirements. So you are more or less just using a proofreading software to find the small errors here and there, and then be satisfied with the outcome and go your merry way into the bank to sell, put all the profits into your bank account. But of course, this is also something that's not correct. The bugs may be sometimes easy to locate, they may be easy to fix from the final product, but the problem is that if you have designed a wrong product, saying that if you have missed some requirements, or you have to make your software leaner, for example, make it work on a lighter hardware, or with the system that doesn't have the same amount of resources, or you have to take into account completely separate set of requirements, or that if you have a problem that your system simply isn't compatible with some design limitations imposed by hardware systems, it means that your quality assurance and quality control work is not only just proofreading all your documentation and finding out the small errors, it's more or less about getting everything to function as required. Okay, so at this point we will take a short break, and I'll continue with the other process models and other things which function to fix the problems of waterfalls and allow us to do software development on the part 2, which will be available right after this presentation.